Alright, this one is comparing a sample mean to a population mean, and in this case, the population standard deviation is unknown. Again, this is a realistic example. If you knew the population standard deviation, you'd probably also know the population mean, and therefore, why would you be taking a sample? Okay, so we're using samples to estimate something about the population. So it's realistic that you only know the sample standard deviation. Okay, so requirements. We need a simple random sample. The population distribution is unknown. So you only have the sample standard deviation S. And then check if your sample size is greater than 30, you're good. If it's not greater than 30, then somewhere in the problem it should say something about a normal distribution. So again, make sure you check those at the beginning of every problem. 3 methods to choose from. Again, the p-value method is going to be our most common one, and that's the one you should use unless you're told otherwise. But I'll show you all 3 ways with our example, and so you know how to do each one in case you need to later. So our example is similar to the sample examples we've been using before. And these first 3 parts go with any method that you would be using, so you should always do all these 3 steps for any method. So no matter if you're doing the p-value, the critical value, or the confidence interval. So the first thing we need to do is check the requirements. So the first requirement is it a simple random sample? It says random sample in the problem. We'll assume it's a simple random sample. It doesn't say otherwise. 2, we don't know the population standard deviation. We only have a sample standard deviation in the problem. So we're good on that. That means we have to use T and not Z. And the third one is checking our sample size. If n is greater than 30, then we don't have to worry about if it's normal or not. And the sample had 42, so we're good on that one. So summarizing the data, we had a claimed mean of 25 miles per gallon. We had a sample size of 42. We have a sample mean of 23.8 and a sample standard deviation, which is S, of 3.12. It gives us an alpha of 0.05 to use in the problem, and then it says different. Okay, so when we go to write our hypotheses, we're going to use not equal to. So hypotheses. We're talking about means, so we're going to say the population mean is equal to the claimed value. And in the alternative hypothesis, the symbol stays the same, the value stays the same. All we change is the sign, and it says different, so we're going to use not equal to. So again, those 3 steps you should do at the beginning. No matter how you're going to solve the problem, do those 3 steps first. So we're going to do the p-value method first. In the p-value method, we need to calculate a value of t, our test statistic, and then find a value of the p-value to go with that. So our sample mean is 23.8. The claimed mean for the population is 25. Sample standard deviation 3.12 divided by the square root of n, which is 42. And we get negative 2.49. Okay. Now, the other thing you need in order to get a p-value when you're doing a t-test is degrees of freedom. Which is n minus 1. And get degrees of freedom of 41. And 41 is not a possible row on the t-table, but 40 is, so you always use the next lowest if you get a degrees of freedom that's not on the table. Okay. Okay, if you were to look that up in the table, so in the row where degrees of freedom equals 40, you kind of go across, and again, we'll show you this in class, but the value of this t, negative 2.49, if you take the absolute value of that, that's what's going to be in the table. So going across the row for degrees of freedom where degrees of freedom equals 40, our value for t is between the numbers 2.704 and 2.423. So this is our number, and it's between these two. Okay, so these two numbers are in the table. And if you were to go up to the top of the column that has 2.704, you'd get a p-value of 0.01. If you go up to the top of the column that has 2.423, you'd find a p-value of 0.02. And since our t is between those two, that means that our p-value must be between these two. And the 0.01 is the lower one, so our p-value has to be bigger than that. And the 0.02 is the bigger one, which means our p-value has to be smaller than that one. Okay. So our p-value is somewhere between 0.01 and 0.02. That is all the more accurate we can get using the t-table to look up a p-value. Again, we can use our calculator to solve this problem, and then we'll have an exact number for a p-value, which is a little bit easier to work with. But either way, if we take our alpha, which was 0.05, any number in this range is less than 0.05. Okay, so no matter what we do for p-value, so it's in there somewhere, it's going to be less than 0.05. So we will reject the null hypothesis. I'm going to show you all three examples, so this one, and then the critical value, and the confidence interval method, and then we'll write out one conclusion in the context of the problem for all three examples. Okay, but again, in the table, the p-value, you're getting a range. If the entire range is less than alpha, we're going to reject the null hypothesis. To use the calculator to solve this problem, it's a t-test in the calculator, and the numbers that you're going to enter are the claimed value from the null hypothesis, the sample standard deviation, the sample mean, the sample size, and the sign from the alternative hypothesis. So let's take a look at how to do that. So in your stat menu, oops, we're looking for tests, and this is a t-test. Okay, we're comparing one sample mean to a population mean, and we know the sample standard deviation only, so it's a t-test. Again, if you had entered a list of numbers into your calculator, you'd use data. If you're given the sample mean and sample standard deviation in the problem, you use stats. So the population mean claimed is 25. The sample sample mean is 23.8. Sample standard deviation 3.12. Sample size 42. In the problem, it was asking if it's different, so we use not equal to, and we calculate. So here's our t, negative 2.49, just like we got doing the equation by hand. But now you can see the p-value, 0.0168, we have an exact number for it rather than just a range. So that makes it a little bit easier to work with. So I will write down over here, we have t is negative 2.49. That's the same, but the p-value, we can be a little bit more accurate. And we're getting 0.0168. And that is less than alpha, which was 0.05. So our conclusion would be reject the null hypothesis. And again, I'll write out a conclusion in the context of the problem once we're done with all three methods. All right, so the next method is the critical value method. We're going to take the value of t that we calculated, And we're basically looking at the absolute value of that, remember, same as when we were looking at z. So we're going to compare 2.49 to a critical value of t. Okay. And actually this is it's a two-tailed test, so we need t alpha over 2. Alpha was 0.05. So alpha over 2 would be 0.025. The other thing we need is degrees of freedom, which is 41, and that's not on their table, so we'd have to use 40. And with all that information, if you were to look that up in the table, you get 2.021. So the critical value of t and our test statistic t, our test t is bigger, and when your test t is bigger, you reject the null hypothesis. Okay. And then again, write out your conclusion in the context of the problem, which I'll do in just a second. The confidence interval method was our last one. So we could use the equation and get a confidence interval, but let's just do a quick reminder of how to use our calculator to do that instead. So in the stat menu, this is a TInterval. We have stats provided in the problem, sample mean, sample standard deviation, sample size, a confidence level. Alpha was 0.05, so we're using 0.95 for our confidence interval level, and calculate. And 22.828 to 24.772. So there's our confidence interval. And again, what we're doing is looking to see if the population mean from the null hypothesis is in this interval or not. So 25 is not in this interval. It would be over here somewhere. So if the claimed value is not in the confidence interval, your conclusion should be to reject the null hypothesis. So all three methods give us the same conclusion, reject the null hypothesis. So what we can say then is that the sample mean that we calculated, or that the person who did the sample calculated, is significantly different from the claimed population mean. We have evidence to say the claimed value for the mean is, we could say, not valid. So it's not a valid claim. Or it could possibly be incorrect. So we are rejecting the claim that the mean is 25. That means it's either not a valid claim or it's an incorrect number. Okay, so again, all three methods, we get the same conclusion, reject the null hypothesis, and then this is how you can write it out in the context of the problem.